Okay, so we've talked about low pass and high pass filters. We will talk about band pass filters as well. But before we get to that, I want to talk about higher order passive filters. So we're not going to go into a huge amount of detail about this, but we will get some basic ones. So remember here, we're just going to look at our first order low pass filter. And remember that our first order low pass filter was a very simple circuit. We had a voltage source here, which was our input, a resistor, and then a capacitor. And then we knew that the cutoff frequency here in radians per second is 1 over RC. And then we also know that R omega C is equal to 2 pi FC. Which actually, we haven't really talked about this in the other lessons, but this really could give us a different equation for using this equation and substituting it in for here. You could get 2 pi FC is equal to 1 over RC. So F sub C is 1 over 2 pi RC. And all this is of course, remember, this is in the units of rads per second, and this is in the units of hertz. Alright, so we saw that. The other thing you should recall, one of the videos when we looked at the magnitude of the output in decibels for different frequencies, we saw that the slope of this was minus 20 decibels per decade. So if we were to draw the graph of this, this would maybe be my cutoff frequency here, 0 dB, and then this would correspond to minus 3 dB. And then of course this slope here is what we're saying is this is minus 20 decibels per decade. That's what we're saying. Alright, so the idea here is we'd like to get a higher order filter, and we've seen some pictures before where, you know, I'm going to go through the same cutoff frequency but then have a steeper slope. So I can get closer to that ideal case, which I'll draw over top of the ideal case here being something like that, which will never obtain that. But we can see here the difference is the green one, we're not letting, we're cutting off the low frequencies much better, in the sense that you know, there's still some frequencies that have some power getting through on this first order, and yeah, we still have some frequencies getting through on the green curve, but they're much lower ones, or closer to the cutoff frequencies, what I should say. Alright, so how do we build something? Well, let's just look at a simple second order low pass filter. So a simple second order low pass filter. And so this would be, that's not V out, that's of course VN. Duh. VN. and then V out is across the second capacitor here. So this is a simple second order low pass filter. Now we could find the transfer function, and it's not the end of the world to do it, but it's like if we did that, we would say, oh wait, I have a voltage here that's unknown, and then this is my output voltage, and of course we're going to use a delta function as an input so that the output is just equal to our transfer function. So Laplace transform, that goes to 1, and this is going to be 1 over SC1, 1 over SC2. And so you would wind up with two equations here, VA minus 1 over R1 plus VA over 1 over SC1 plus VA minus VO over R2, and this is all equal to 0. And then you'd also have V out minus VA over R2 plus V out minus, not minus anything, it would be 0, V out over 1 over SC2 equals 0. Now this would be our second equation, and then now we have to start solving systems of equations with unknowns here. So we'd really want to use like a symbolic solver or something like that. This one's pretty easy, but if we get into like a third order or a fourth order, you'd see it just becomes messy. So to do that, let's see what we'd have here. Well, let's go ahead and solve this one. It's not too bad. So I'm going to rewrite equation 1 here, and this would be VA minus 1 over R1 plus SC1 VA plus VA minus VO. Whoa. My OneNote just crashed on me. Let's hope I didn't lose everything. I lost a little bit. Don't know why my OneNote's been kind of flaky recently. So as I said, we're going to solve this. So we have VA minus 1 over R1 plus SC1 VA plus VA minus VO over R2 equals 0. And then I'm simply going to multiply through by R1, R2. So we'd have R1 VA minus R1 plus S C1 R1 R2. Whoops, these should be 2's here. Plus R1 VA minus R1 V out. And is it going to crash again on me? I'm going to pause. Okay, so I got it back up here. It might have done a really weird jump and change the way it did because again it didn't save some of my work here. Hopefully we are done crashing. I've restarted the computer and everything, so hopefully that's all taken care of. Alright, so let's go ahead and kind of separate this as far as VA and everything. So we have an R2 plus SC1 R1 Okay, so there's another major jump here. I had to just delete the notebook. It got corrupted, which is why it kept crashing on me. So this is kind of where we picked up here. So we had this first equation and we had rewritten it here, and then I was multiplying through. Let's just remind us what I was doing. I was multiplying through by R1, R2. And so what I wound up with getting here was I got VA minus, R2 VA minus R2 plus SC1 R1 R2 VA plus VA R1 minus V out R1 equals 0. And so Let's go ahead and clean this up a little bit here. So I would have VA times R1 plus R2. I'm going to go ahead and put those in parentheses. So let me make sure I take all my terms. So that's these two here. And then I got to get that one. So plus S C1 R1 R2. I already have the VA. Minus VO R1 is equal to R2. And then if we look at this equation right here, we would have V out minus VA is equal to not equal, plus S C2 R2 V out is equal to 0. Now I would solve this for VA because I'm trying to find V out anyway. So I just get VA is equal to V out plus SC2 R2 V out, which of course is equal to 1 plus SC2 R2 times V out. So now we're going to go ahead and substitute this back in. And so we'd have V out times 1 plus SC2 R2 I don't know why I put two parentheses there. And I'll put this in bracket a little bit here. R1 plus R2 plus SC1 R1 R2 minus V out R1 is equal to R2. Okay, now it looks like it's kind of messy here, and we're going to clean this up here and go ahead. We're not going to actually do all the details here, but we'll clean this up here. So let's go ahead and multiply this out. So if we multiply it out, I'd have V out times, well, I'm going to have 1, because the reason I kind of put this in parentheses is now this is kind of a binomial, like this would be my first term, so I can have first times outside times inside, last, the whole classic FOIL. So you'd have R1 plus R2 plus SC1 R1 R2 plus, there's a little hair on my tablet here, sorry about that. You probably didn't see it, but it was getting in my way, it was annoying. So we've done the ones, now we have to do the S R2 times R1 plus R2 plus S squared C1 R1 R2, and oops, I forgot the C2 there, and the R2 is now squared, and this is all equal to R2. Okay, so then my transfer function, if I want to, it's going to be messy and we're going to clean it up a bit. My transfer function then just is V out, so it is equal to R2 divided by this big mess here, R1. Well, let's go ahead and write it in descending order. S squared R1 R2 squared C1 C2 plus okay, that's what it was. I'm like, I made a mistake somewhere and it's right here. Because that should be SC2 R2 times R1 plus R2. Because that's, yeah, SC2 R2. So let's go back and make sure I multiplied everything out again here correctly. R1 plus R2 times 1, R1 plus R2 times 1, SC R1 R2 times 1, SC1 R2 1, C2 R2 times that, C2 R2 times that, plus S squared, and I forgot something here. There is, I forgot this minus R1. Is equal to R2. And that would be S squared C1 R2. Yeah. Okay, we're good now. So S squared R1 R2 squared C1 C2. It looks like a mess. It will actually clean up, believe it or not. But it looks like a mess right now. Plus S times R1 R2 times C1 plus C2 R2 times R1 plus R2 then I have a plus R1 and a minus R1, so those are going to cancel, so I'm going to be left with plus R2. Okay, so that is my transfer function, but I want a 1 in front of this here, so I am going to multiply this by 1 over S, not 1 over S, 1 over R1 R2 squared C1 C2, 1 over R1 R2 squared C1 C2. And so we'll have the transfer function then being h at s, well, you're going to wind up with a 1 divided by R1 R2 C1 C2 divided by S squared plus S. Let's go ahead and multiply in through here. So if we multiply it in here, you're dividing by you're multiplying by 1 over R1 R2 squared C1 C2. So this would be 1 over R2 C2 plus 1 over R1 C1 R2 times R1 plus R2 plus 1 over R1 R2 C1 C2, which we're going to clean up one more step here. And we wind up with a transfer function of 1 over R1 R2 C1 C2 divided by S squared plus S times 1 over R2 C2 plus, okay, well then this R1 is going to cancel out with that, So you'd have 1 over R2 C1, and then the R2 is going to cancel. And we'd have plus 1 over R1 C1 plus 1 over R1 R2 C1 C2. Now this looks pretty ugly, but believe it or not, this thing does factor. We're not going to go through and show that it factors, but you can see that even though the circuit looks relatively simple here, we suddenly get kind of a mess of a transfer function to have to deal with. So fortunately with these higher order filters we can kind of see a pattern here. Well, let's just, I'm going to end it here and we'll start at the pattern on the next video.